Hello, so we're back. Simplifying equations is what we have up here. This one is pretty lengthy. This is the problem here. It is an equation because it has an equal sign, so you do have to solve, but it has a few more steps to it. I wanted to make it a little bit more complicated, a little bit more challenging. How about that? 2x plus 3x minus 5 plus 7 equals 10x plus 3 minus 6x minus 4. And I put the steps in blue so you could see what steps to take. Simplify both sides first. Combine like terms on each side of the equation. So on this side, I have 2x plus 3x, I get 5x. And then I have negative 5 plus 7, which is the same thing as 7 minus 5, that's 2. Then I'm going to take the 10x minus the 6x would give me 4x. And 3 minus 4 would give me a negative 1, minus 1. Now, next, you're going to put all the variables on one side and all the whole numbers on the other side. So that means I'm going to take the negative 4, just changing my ink color here, and I'm going to minus 4. Over here, I said negative 4, but minus the 4 because what's the inverse of adding? Subtracting. And so minus 4x here and minus 4x here, and I get 1x plus 2 equals negative 1. I kind of ran out of space on my board. You can go down on your paper if you want, but I moved it over here, and I have 1x plus 2 equals 1, and then I subtract 2 on both sides, and I have x equals negative 1. And there we have it. So that would be the answer. These would be the steps to take. Next, I have one that has distributive property in it. You would distribute what's on the outside and multiply with what's on the inside. Kind of recall that from our properties of math. And so, but up here is a minus sign. And you really have to distribute the negative into each one. So I kind of write an imaginary one to keep it clear to me that I still have to multiply that with each one in there. And so I kind of did this up here. This is kind of what I do in my head, but you may have trouble trying to figure that out. So I did the next step. 6 times 2a, 6 times negative 1. Negative times 11a and a negative times a 6. And then equals 7. Bring that down. Then I have 12a minus 6 minus 11 minus 6 equals 7. And then I combine them together. 12 minus 11 is 1a. Negative 6 minus 6, keep the signs, add the number. I get a negative 12 minus 12. And I have my variable, but now I need to get the variable by itself, and I have to do the inverse operation, and the opposite of subtracting is to add. And I add 12 to one side, and whatever I do to one side, I have to do to the other side. And then 7 plus 12 is 19. So a equals 19. How do I know if it's right? Well, I would check it, and that's what I wrote here. 1 times 19. Now, where did that come from? That came from this. I'm not putting that 19 up in this long problem up here. That ain't happening. I'm going to take the smaller version of it. I'm going to do 1 times 19 minus 12. And then I'm going to get 7, and 7 equals 7. Then yes, it's correct. You can always check your problems by substituting it in with the variable to make sure it's correct. I gave another one because this one has a negative variable, and you can never have a negative variable. You will never ever see negative x equals whatever it is. It will always be a positive x. So you got to get rid of the negative. And what I gave you was 3 minus x equals 7. And then I subtract 3 from both sides because I got to get the x by itself. I have a negative x equals 4. And then this is that little imaginary 1. Any number not in front of a variable is always assumed a 1. And so, again, I just write a little itty bitty imaginary 1 for myself. You can do it for you. It helps me. And then I divide by -1. I take the sign with it. And then it gives me just a positive x. This one is a positive divided by a negative, and that would give me a negative 4. And that is how you solve that. But never, ever, ever will ever be a negative variable for negative x equals whatever. Never. And now it's your turn. And again, you're going to pause, write this down, and then I'm going to show you how to do it. So, this is going to be combining this side, which is 5n. And I'm going to move this 4n over here with his buddy, the 5n. And to do that, I have to do the opposite. I have to do the inverse operation, which is to add, but the opposite is to subtract. Sorry, I think I said that wrong, but you subtract it from each side. Whatever I do to one side, I have to do to the other. And I have just an n. That wasn't so hard. Let's look at this one. This one's a little longer, has 3 terms on each side. We can combine a few things. 4p minus p is going to be 3p minus 11. 2 plus 2p minus 20, negative 20 and 2. I subtract the numbers, keep the sign of the bigger number. I'm going to get it negative 18 plus 2p. And then I'm going to move 2p over with this buddy. I like subtracting the smaller numbers from the bigger numbers. It's just that easy. Does it matter if I take negative 3p and put them over here? Not really. You're going to still get the same answer in the end. And then I'm going to get p by itself. What's the opposite of subtracting? Adding. If I add 11 to this side, then I'm going to add 11 to this side. And negative 18 plus 11 is going to give me a negative 7. Subtract the numbers, go with the sign of the bigger number. And that would be that. I'm not going to check it. I am confident that both of my answers are correct. But you can go back in and plug that negative p into this problem, and you could plug that positive 7 into this problem. Or that negative 7, sorry. Negative 7 into the p, and a positive 7 into the n over here. Next ones. So I gave you a couple more, and again, pause, write them down, see if you can solve them yourself, and then come back and see if you got the answer right. So let's do them together. Multiplying, distributive property into each one. Combine like terms. 15 minus 9 is 6. 5 minus 8 is negative 3z. Negative 4z. I'm going to add 3z and add 3z over here. It doesn't look like it's going to be too bad. Okay, so then I'm going to move this over here because I didn't leave myself enough room. So I have 6 equals negative 1z. Now remember, that will never be a negative. That is not the answer. You have to get rid of it. And to get rid of it, this is multiplying, and the inverse operation is to divide. And so I have a positive z, and that's going to be a negative 6. And that would be the answer for that problem. Which worries me now because I might not have left myself enough room for this one, but we'll see what we can do with it. I'm distributing the negative into each of these terms. I have 15 minus 6 plus 7k equals 2 plus 6k. I can, 15 minus 6 is 9. I'm going to move my minus 6k over here, and I'm going to minus my 9 over here. and just cross them out since I'm running out of room. And then 7 minus 6 is just a k. And 2 minus 9 is a negative 7. They must like 7s, right? That's another one with a 7. And I'll put that final answer here. And so that is how you do those problems. At this point, I would say any questions, but since we're recording, you can put them in the comments if you have any questions. I do believe they will come to my email that I have this set up on. But, you know, go back and really look what I did, what steps I followed. Hopefully you can see it clearly, and I explained it clearly. And then next, we're going to stop there.